When we first learned about vector arithmetic, we learned how to add and subtract two vectors. We also learned how to multiply a scalar with a vector, but we didn't have any way to multiply two vectors together. Now in this section, we're going to learn about the first vector-vector product of two vector-vector products we're going to learn about in this class. This is not a perfect analog of multiplication of numbers. But this vector-vector product has a lot of properties like multiplication, which is why we call it a product. So we're going to learn about the dot product. So let me start by defining it. Let's take two vectors in Rn. The dot product between u and v is defined as, so notationally, we take u and we just put a dot between u and v. So dot product because we're using a dot in between to signify the product. Okay? So if u has components u1 to un, and vector v has components v1 to vn, then the dot product of these two vectors is just going to be the product of the corresponding components added together. So I'm going to multiply first component of u with first component of v, and second component of u with second component of v, and so on. So I get to the end. And then I add them all together. Okay, notice what this means. This means that at the beginning, I start with two vectors, right, u and v. And at the end, I multiply all the corresponding components, and then I add them together, which means at the end, I do not have a vector. This is a scalar. And for this reason, the dot product is sometimes called the scalar product. Okay, so let's see an example. Let's let u be -3, 4, 2. And let's let v be 1, 5, -3. Then if I take the dot product of u and v, that's the dot product of vector -3, 4, 2 with the vector 1, 5, -3. And I just want to emphasize with this dot product, the dot is not optional. With normal numerical multiplication, if I do 2 times 3, that's the same as 2 times 3, that's the same as 2 times 3, all the same thing. That's not true with vectors. If I did u dot v, that's different than u cross v. That's another kind of product that we haven't learned about yet, but we will. And that's different than u parentheses v, which is just not defined. Okay, so make sure you're using the correct symbol. Okay, you can't leave the dot out. The dot is essential to indicate that we're dealing with a dot product here. Okay, so all I'm going to do is I'm going to multiply corresponding components. So first component of u times first component of v, and second component of u times second component of v, and third component of u times third component of v, and then add them together. Very frequently, I get students who try to put commas here and say, hey, we've got a vector. These are the components of my vectors. But you do not get a new vector from a dot product. You get a scalar. So I'm going to multiply corresponding components and then add them together. I will have one single number at the end, not a vector. So negative 3 times 1 is negative 3, plus 4 times 5 is 20, plus 2 times negative 3 is negative 6. Negative 3 plus 20 plus negative 6 is 11. And that's the dot product of u and v. Now, there are a lot of really useful geometric intuitions that we can get from the dot product. It tells us a lot about the geometry of the vectors. Very useful in practice. We're going to learn about that, though, in a future section. For now, we're just going to focus on how to take the dot product and the properties of the dot product.